Hello, in this lecture we'll find out the area of a circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. In addition, we know that side AB of this quadrilateral ABCD is equals to 2 units in its length, side BC equals to 8 units, and side DC also equals to 8 units in its length. This is angle ABC, that is equals to 90 degrees in size. And this is angle DCB, that is also a right angle. Again, our mission is to find out the area of this circle. So, first of all, we will do a construction. That is to say, we will extend side DA and side CB of this quadrilateral by a straight line until they touch each other. So this is their touching point. We will define the touching point as point M. We define this angle as angle theta. So in the right triangle DCM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? According to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here, 90 degrees minus theta plus theta is 90 degrees. And 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. In the next step, we will focus on this line segment BC. Line segment BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. We extended the straight line CB by a straight line, and the result is a line segment CM. When you extend a straight line by a straight line, the result must be a straight line. Therefore, CM is a straight line. So, we focus on the upper side of the straight line CM at point B. Here, at the upper side of CM at point B, the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? This angle equals to 90 degrees, plus the missing angle, that's actually angle ABM. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. Okay. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees in its size. So, we have the small right triangle MBA. In this small right triangle MBA, this angle equals to theta, this angle equals to 90 degrees, it is a right angle, therefore the missing angle here must be equal to 90 degrees minus theta. according to the same rule that the sum of the angles in any triangle is equal to 180 degrees. Okay, so in the next step we will prove that the big right triangle DCM is similar to the small right triangle MBA. So I write it down. The big right triangle DCM is similar to the right small triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles they are both equal to 90 degrees, therefore they are equal to each other. So this is the angle DCM in the right triangle DCM, and it is equals to this angle that is actually angle ABM in the right small triangle MBA. Repeat again. Angle DCM in the right big triangle DCM is equals to angle ABM in the small right triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so you can write down that angle theta equals to itself is a common angle that belongs to both triangles. So if we relate to this angle theta, as it is belongs to the right big triangle DCM, it will be called angle DMC. And it equals to itself. So if we relate to this angle theta as it belongs to the small right triangle MBA, then it will be called angle AMB. Repeat again. This equation means that angle theta equals to itself, just call to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MDC in the right big triangle DCM, and it equals to this angle, that is actually angle MAB in the small right triangle MBA. Repeat again. Angle MDC equals to angle in the right triangle DCM equals to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually proved that all the three angles in the right triangle DCM are correspondingly equal to all the three angles in the right small triangle MBA. Therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down. the right triangle, the right big triangle DCM is similar, this is the sign of similar, to the right small triangle MBA, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side DC in the right big triangle DCM over side AB in the right small triangle MBA equals to side CM in the big right triangle DCM over side BM in the right small triangle MBA. Repeat again. We derive that DC over AB equals to CM over BM. DC equals to 8 units in its length over AB. AB is 2 and it equals to CM over BM. What is the length of CM? From the drawing it is very easy to see that CM in total equals to CB plus BM. That is to say CM equals to CB, that is 8, plus BM, that is the missing side. So in total CM equals to 8 plus BM. So here we substitute CM in this equation by 8 plus BM, and we have to divide it by BM. Here 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM and we get that 4 BM equals to 8 plus BM. Here we subtract BM from this equation. We subtract BM from this equation and we get that 4 BM minus BM is 3 BM. So 3 BM equals to 8. Here we divide this equation by 3. And finally, we will get that BM equals to 8 over 3 units in its length. Okay, BM equals to 8 over 3 units. Side BM equals to 8 over 3 units in its length. In the next step, we will focus on this small right triangle MBA, and we will implement the Pythagoras theorem on this right triangle MBA. Here by PT is the probation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle MBA is AM, therefore the square of the hypotenuse is AM squared. So AM squared must be equal to AB squared plus BM squared. Repeat again. According to the Pythagoras theorem, in the right triangle NBA, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, must be equal to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BM squared. Here, BM, we found out that BM equals to 8 over 3, therefore BM squared is 8 over 3 squared, that is 64 over 9. So in conclusion, we found out that AM squared equals to 4 plus 64 over 9, so here we will multiply 4 by 9 and then we will divide it by 9 in order to have a common factor with 64 over 9. 4 times 9 is 36, so in total in the numerator of this expression we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So AM squared equals to 100 over 9. Here we will take a root out of this equation and we get that AM equals to the square root of 100 over 9. So AM squared equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So in conclusion, we found out that the length of the hypotenuse AM is equals to 10 over 3 of it. AM equals to 10 over 3 of it in its length. In the next step, we will do another construction. That is to say, we will draw perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. It is absolutely possible to do it because we can draw the perpendicular on any point on BC. We have infinite points that we can draw the perpendicular. Therefore, we'll choose the point on BC that is exactly also tangent to this circle. Therefore, it is possible to do it. So first of all, this angle equals to 90 degrees. And this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular and BC as point T. We will define the point of tendency of the perpendicular with the circle as point K. In the next step, we will extend the perpendicular TK by side line until it touches side AD. We will define the touching point of the extended perpendicular TK we define the touching point of the extended perpendicular TK with AD as point L. By doing this construction, we actually created here the right middle triangle, triangle MLT. In the right middle triangle MLT, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. In the next step, we will define the center of this circle, this point as O. We will define the point of tendency of tangent PT with this circle as point H. And finally, we will define the point of tendency of tangent AB with this circle as point G. We will join points O and H together by straight line. Point O is the center of the circle, point H is the point of the circle itself. This is exactly the definition of a radius. That is to say, OH, line segment OH is the radius of the circle. We define the radius of this circle as x, therefore OH equals to x units in its name. It is the radius of this circle. Here we can implement rule 1. I'll repeat quickly on rule 1. We need to rule 1. A tangent to the circle is perpendicular to the radius drawn to its point of tendency. In the drawing we have a circle and we have also tangent AB. This is tangent AB, this is tangent to this circle is point M. Point M is the point of tendency. And we also have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule 1. We can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius OH that is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and G together by straight line. OG is the radius of this circle, that is equal to x. Again, here we have the radius OG that is drawn to point G, therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points O and K together by straight line. Line segment OK is the radius of this circle that is equal to x according to our definition. Again, the radius OK is drawn to point K, that is the point of tendency. Therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. We focus on this small quadrilateral. We focus on this small quadrilateral OKHT. Inside this quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of this fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle must be equal to 90 degrees in its size. In order to complete the sum of the angles in this quadrilateral to 360 degrees, the missing angle must be equal to 90 degrees. So, inside quadrilateral OKHT we have 4 right angles. Therefore, we relate to this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OK must be equal to the opposite side HT in rectangle OKHT. But OK equals to x, therefore HT must be also equal to x units in its length. Likewise, we repeat on the same process on this quadrilateral, the small quadrilateral OGBH. Inside this small quadrilateral, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, we can relate this quadrilateral as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OG must be equal to side HB in rectangle OGBH. But OG equals to x, therefore BH must be also equal to x units in its length. In conclusion, we know that the line segment BT in total equals to x plus x, that is 2x. So I write it down. Line segment BT equals to 2x units in its length. Okay. In the next step, we will prove that the right middle triangle, triangle LTM, is similar to the right small triangle, triangle MBA. So I write it down. We prove that the right middle triangle, triangle LTM, is similar to the right small triangle, triangle MBA. So, why the middle triangle is similar to the small triangle MBA? First of all, those two angles they are both equal to 90 degrees, therefore they are equal to each other. So actually, this is angle LTM. In the right middle triangle LTM, and it is equal to this angle that is actually angle ABM in the right small triangle MBA. Repeat again. Angle LTM in the right middle triangle LTM equals to angle ABM in the right small triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So, if we relate to this angle, angle theta, as it belongs to the right middle triangle LTM, it will be called angle LMT. Angle theta equals to itself. So if we relate to angle theta as it belongs to the right small triangle MBA, it will be called angle AMB. Repeat again. this equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle MLT in the right middle triangle MLT, and it is equals to this angle that is actually angle MAB in the right small triangle MBA. Repeat again. Angle MLT in the right middle triangle LTM equals to angle MAB equals to angle MAB in the right small triangle MBA. They are both equals to 90 degrees minus theta, therefore they are equal to each other. So we actually found out that all the three angles of the right middle triangle LTM are correspondingly equal to all the three angles in the right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The right middle triangle LTM is similar. Again, this is the sign of similar to the right small triangle MBA according to angle similarity rule. And from the fact that the middle triangle is similar to the right small triangle, we will derive that the following relationship exists between their sides. We derive that side LT in the right middle triangle LTM over side AB in the right small triangle ABA equals to side TM in the right middle triangle LTM over side BM in the right small triangle MBA. Repeat again. We derive that LT over AB equals to TM over BM, and also that it is equals also to the hypotenuse LM, to the ratio between the hypotenuse LM in the right middle triangle LTM over the hypotenuse of the right small triangle MBA, that is actually AM. Total, we found out that LT over AB equals to TM over BM, and it is also equals to LM over AM. LT, this side LT is the missing side, so we will leave it as it is. LT over AB. AB is 2, so we substitute AB by 2. Okay. And it is equals to TM over BM. What is the value of TM? From the drawing, it is very easy to see that Tm in total equals to Tb plus Bm. That is to say, Tm equals to Tb, that is 2x, plus Bm, that is 8 over 3. So in total, Tm equals to 2x plus 8 over 3. So here we substitute Tm by 2x plus 8 over 3 divided by Bm. Bm equals to 8 over 3, so we substitute Bm here by 8 over 3, and it is also equals to Lm over Am. What is the value of Lm? Lm is the bottom of the right middle triangle LTM. Lm in total equals to La plus Am. That is to say, Lm equals to La, that is the missing side, plus Am, that is 10 over 3. So in total, Lm equals to La plus 10 over 3. So we substitute Lm here by La plus 10 over 3 divided by Am. What is the value of Am? Am equals to 10 over 3. So we substitute Am here by 10 over 3. In conclusion, found out that LT over 2 equals to 2x plus 8 over 3 over 8 over 3, and it is also equals to LA plus 10 over 3 or 10 over 3. So we focus on this long equation. In this long equation, those two sides of those two expressions, they are equal to each other. Therefore, we create equation 1 from those two sides of expressions that are equal to each other. Okay, so according to equation 1, we get that LT over 2 equals to 2x plus 8 over 3 over 8 over 3. So we actually found out that according to equation 1, LT over 2 equals, here on the other side of equation 1, we have 2x plus 8 over 3. So here we will substitute, we will multiply 2x by 3, and then we will divide it by 3 in order to have a common factor with 8 over 3. 2x times 3 is 6x. So in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. We focus on this side of this equation, equation 1. We have here 3 in the numerator and 3 in the denominator, so 3 get cancelled. After we cancel 3, this side of the equation 1 we left only with 6x plus 8 divided by 8, and it is equals to the other side of the equation 1, that is 8 LT over 2. So here we multiply this equation, we'll multiply this equation 1, and we get that according to equation 1, 8 times LT equals to 2 times 6x plus 8. Here we divide this equation 1 by 2. And we get that 8 LT over 2 is 4 LT, and it equals to 2 over 2 is 1, so in the other side of equation 1, this side of equation 1, we left only with 6x plus 8. So here we'll divide this equation 1 by 4, and finally we'll get that the length of line segment LT is actually equals to 6x over 4 is 1.5x plus 8 over 4 is 2. So in conclusion, we found out that the length of line segment LT is equals to 2 plus 1.5x. So this line segment LT equals to 2 plus 1.5x. So I write it down in the drawing itself. Then the length of this line segment LT or side LT is equals to 2 plus 1.5x. We will continue to focus on this long equation. Here we have those two sides that are equal to each other. Therefore, we get equation 2 from those two sides that are equal to each other. So according to equation 2, 2x plus 8 over 3 over 8 over 3 equals to LA plus 10 over 3 over 10 over 3. Repeat again. According to equation 2, we actually found out that 2x plus 8 over 3 over 8 over 3 equals to LA plus 10 over 3 over 10 over 3. We focus on this side of equation 2. So here we have 2x plus 8 over 3. So we'll multiply 2x by 3 and then we'll divide it by 3 in order to overcome factor with 8 over 3. 2x times 3 is 6x. So in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it also. We have to divide it also by 8 over 3. We focus on the other side of this equation, equation 2. This side of equation 2, we have LA plus 10 over 3. Here we multiply LA by 10 over, by 3, and then we divide it by 3 in order to overcome a factor with 10 over 3. 3 times LA is 3LA. So in total, in the numerator of this expression, we will have LA plus 10 divided by 3, and we have to divide it also by 10 over 3. In this side of equation 2, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. In the other side of this equation, equation 2, we have here 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. So what is left from equation 2 after we cancel 3 from on both sides of this equation? In this side of equation 2, we left only with 6x plus 8 divided by 8. That equals to another side of equation 2, we left only with 3LA plus 10 divided by 10. Here we cross multiply this equation, equation 2, and we get that according to equation 2, 10 times 6x plus 8 equals to 8 times 3LA plus 10. Here we divide this equation, equation 2 by 2, and we get here that 10 over 2 is 5. Inside the brackets we have 6x plus 8. This equals to 8 over 2 is 4. Inside the brackets we have 3LA plus 10. So here we'll open the brackets on both sides of this equation, equation 2. And we get that according to equation 2, we have in this side of equation 2, 5 times 6x is 30x, plus 5 times 8 is 40. That is equals to 4 times 3LA is 12LA. Plus 4 times 10 is 40. So here we have 40 on both sides of this equation 2, so 40 will get cancelled. After we cancel 40, we're left only with 30x, that is equals to 12LA. So here we divide this equation 2 by 12. And finally, we'll get that LA equals to 30x over 12 is 2.5x. So actually we found out that this line segment LA or side LA equals to 2.5x. In the next step, I will copy this small quadrilateral ALBT with the circle that is inscribed inside it, and we'll implement in this drawing, the new drawing, rule 2. So actually this is the small quadrilateral ALBT with the circle that is inscribed inside it. So here we will define the point of tendency of tangent AL with this circle as K. We will define the point of tendency of tangent AB with this circle as M. We will define the point of tendency of tangent BT with this circle as H. And finally, we will define the point of tendency of tangent LT with this circle as G. I will remind you quickly what is rule 2. According to rule 2, the lengths of two tangents from a common external point to a circle are equal. In the drawing we have a circle and also this common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. According to this rule 2, they are equal to each other. That is to say, PA equals to PB, or the length of tangent PA equals to the length of tangent PB. PA equals to PB. We can actually implement rule 2 in our drawing. We'll focus on the common external point, point A. From the common point, point A, we have two tangents to this circle, tangent AK and tangent AM. According to rule 2, they are equal to each other. That is to say, AK, tangent, the length of tangent AK equals to the length of tangent AM according to rule 2. So if we define the length of tangent AK as A, then the length of tangent AM must be also equal to A because they are equal to each other. So, we found out actually, we conclude that AK equals to AM, and it is also equals to A according to our definition. In the next step, we will focus on this common external point, point B. From this common external point, point B, we have two tangents to this circle, tangent BM and tangent BH. And according to rule 2, they are equal to each other. That is to say BM equals to BH. So I write it down. The length of tangent BM equals to the length of tangent BH according to the same rule, rule 2. So, if we define the length of tangent BH as B, then the length of tangent BF must be also equal to B because they are equal to each other. In the next step, we will focus on this common external point, point T. From this common external point, point T, we have two tangents to this circle, tangent TG and tangent TH. And according to rule 2, they are equal to each other. That is to say, TG equals to TH. So I write it down. TG equals to TH. According to the same rule, rule 2. So if we define the length of tangent TG as C, then the length of tangent TH must be also equal to C because they are equal to each other. TG equals to TH. So in conclusion, we found out that TG equals to TH equals to C according to our definition. And finally, we will focus on this common external point, point L. From this common external point, point L, we have two tangents to this circle, tangent LK and tangent LG. And according to rule 2, they are equal to each other. That is to say, LK equals to LG. The length of tangent LK equals to the length of tangent LG. So if we define the length of tangent LK as D, then the length of tangent LG must be also equal to D because they are equal to each other. So in conclusion, we found out that KL equals to LG and it is equals to D according to our definition, according to the same rule, rule 2. In the next step, we join points AB, we join side AB to side LT. Again, we join side AB to the opposite side, side LT, in this quadrilateral ALBT. So what is the value of AB plus the opposite side, side LT? From the drawing it is very easy to see that AB equals to A plus B and LT equals to C plus D. So in total AB plus LT equals to A plus B plus C plus D. Likewise, we join side AL to the opposite side, side BT. So what is the value of AL plus BT? From the drawing it is very easy to see that AL plus BT equals to A plus B plus C plus D. Again, AL plus BT equals to A plus B plus C plus D. So AL plus BT also equals to A plus B plus C plus D. So actually, those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. That is to say, AB plus LT equals to AL plus BT. Repeat again. We can found out that AB plus LT equals to AL plus BT. AB equals to 2 units in itself, therefore we substitute AB by 2 plus LT. LT, this is my segment LT, this is equal to 2 plus 1.5x. So we substitute LT by 2 plus 1.5x. Repeat again, actually, we substitute LT by 1.5x and we substitute AB by 2 in this equation. And it is also equals to AL plus LT. So this is one side of the equation, is equals to the other side of the equation. On the other side of the equation we have AL plus BT. What is the value of AL? AL equals to 2.5x. Therefore we substitute AL in this equation by 2.5x plus BT. What is the value of BT? We have already found out that BT equals to 2x, so we substitute BT in this equation by 2x. So in conclusion, we found out that 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4. So in total, in this side of the equation, we have 4 plus 1.5x. That is equals to 2.5x plus 2 is 4.5x. So in conclusion, we found out that 4 plus 1.5x equals to 4.5x. Here, we subtract 1.5x from this equation. And finally, we get that 4 equals to 4.5x minus 1.5x is 3x. So in conclusion, we found out that 4 equals to 3x. Here we'll divide this equation by 3, and finally we find out that x equals to 4 over 3 units in its length. X equals to 4 over 3. Actually, x is the radius of this circle that is equal to 4 over 3 units in its length. Our mission is to find out the area of this circle. And we know that the area of any circle is equal to pi times the radius of the circle squared. Therefore, the area of our circle will be equal to pi times the radius squared. The radius is x, therefore the radius squared is x squared. So the area of our circle is pi times x squared. And we just right now found out that x equals to 4 over 3. If x equals to 4 over 3, it means that x squared is 4 over 3 squared. So in conclusion, we found out that the area of our circle equals to pi times 4 over 3 squared. So it is pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, we found out that the area of our circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Repeat again. The area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the area of this circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have this circle. In addition, we know that side AB equals to 2 units, side BC equals to side CD equals to 8 units. This is angle ABC that is equal to 90 degrees in its size, and this is angle DCB that is also equal to 90 degrees in size. Again, our mission is to find out the area of this circle. In the first step, we actually did a construction. That is to say, we extended side DA and side CB of this quadrilateral ABCD by straight line until they touch each other. This is their touching point. We defined their touching point as M. Then we define this angle as theta. So in the right big triangle DCM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Okay, then we focus on this line segment BC. Line segment BC is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then we extended the straight line CB by straight line, and the result is CM. When you extend a straight line by straight line, the result must be a straight line, therefore CM is a straight line. So if you focus on the upper side of the straight line CM, here on this, this point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is a right angle, plus the missing angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the upper side of CM at point B to 180 degrees, the missing angle must be equal to 90 degrees. Therefore, triangle ABM is a right triangle. So in the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. According to the sum rule, then the sum of the angles in the triangle is equal to 180 degrees. Then we proved that the right big triangle DCM is similar to this right small triangle, triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the right big triangle DCM are correspondingly equal to all the three angles of this right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side DC in the right big triangle DCM over side AB in the right small triangle MBA equals to side CM in the right big triangle DCM over side BM in the right small triangle MBA. Repeat again. We will derive that DC over AB equals to CM over BM. DC is 8, AB is 2, and it equals to CM over BM. What is the length of CM? From the drawing it is very easy to see that CM in total equals to CB plus BM. That is to say CM equals to CB, that is 8, plus BM, that is the missing side. So in total CM equals to 8 plus BM. Here CM equals to 8 plus BM, and we have to divide it by BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. If we multiply this equation by BM, we found out that 4BM equals to 8 plus BM. Here we subtract BM from this equation, and finally found out that 4BM minus BM is 3BM, so 3BM equals to 8. Here we divided this equation by 3 and found out finally that BM equals to 8 over 3 is in its length. Here this side BM equals to 8 over 3 is in its length. Then we focus on this right small triangle MBA. We implemented the Pythagoras theorem on this small right triangle MBA. According to the Pythagoras theorem, there is small right triangle MBA, AM squared equals to AB squared plus BM squared. Repeat again. In the right triangle MBA, the right small triangle MBA, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, equals to AB squared. AB is 2, therefore B squared is 2 squared, that is 4, plus BM squared. BM is 8 over 3, therefore BM squared is 8 over 3 squared, that is 64 over 9. So we found out that AM squared equals to 4 plus 64 over 9. So here we multiplied 4 by 9 and then we divided by 9 in order to work out factor with 64 over 9. 9 times 4 is 36, so in total, in the numerator of this expression, we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So if we found out that AM squared equals to 100 over 9, here we took out of this equation and finally found out that AM equals to the square root of 100 over 9. So the square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So in conclusion, we found out that the hypotenuse AM equals to 10 over 3 units in its length. This is the hypotenuse AM of the right triangle BM, and BA is equals to 10 over 3 units in its length. Then we did another construction. That is to say, we drew perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular and on BC as T. And the perpendicular on side BC as T. Then we defined the point of tendency of the perpendicular with this circle as K. Then we extended the perpendicular TK by straight line until it touches side DA. We define the touching point of the extended perpendicular TK with side DA as L. By doing this construction, we created the right mid triangle, triangle LTM. In the right mid triangle, triangle LTM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay, then we define the center of this circle as O, this point, and we define the point of tendency of tangent BT with this circle as H. We define the point of tendency of tangent AB with this circle as G. We define the radius of this circle as X. And we join points O and H together by a straight line. Point O is the center of the circle, point H is the point of the circle itself, therefore OH is the radius of this circle that is equal to X, according to our definition. Here, the radius OH is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever your radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius AO. If BT is perpendicular to AO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Then we join points O and G together by a straight line. OG is the radius of this circle that is equal to X. The radius OG is drawn to point G. That is the point of tendency. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Likewise, we join points O and K together by a straight line. Line segment OK is the radius of this circle that is equal to X. The radius OK is drawn to point K. Therefore, according to rule 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. So, in the right, in this small quadrilateral OKHT, we have 1, 2, 3 rectangles. The sum of 3 rectangles is 270 degrees, plus the fourth angle in total must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrilateral to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral OKHT we have 4 right angles. Therefore, we can relate to this quadrilateral that has 4 right angles as a rectangle. And we also note that the opposite sides of a rectangle are equal to each other. That is to say, side OK must be equal to side HT in rectangle OKHT. But OK is X, therefore HT must be also equal to X. Likewise, we repeated on the same process on this small quadrilateral OGBH. Inside this quadrilateral we have 1, 2, 3 rectangles, therefore the fourth angle must be also equal to 90 degrees. Therefore, we can relate to this quadrilateral OGBH as a rectangle. In rectangle OGBH, the opposite sides must be equal to each other. That is to say, side OG must be equal to the opposite side HB. But OG equals to X, therefore HB must be also equal to X. So in conclusion, we found out that this line segment BT in total equals to X plus X, that is 2X. Here BT equals to 2X units in its length. Then we proved that the right middle triangle, triangle LTM, is similar to the right small triangle, triangle MBA. So why the middle triangle is similar to the small right triangle MBA? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually we found out that all the three angles of the right middle triangle LTM are correspondingly equal to all the three angles in the right mid triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that LT over AB equals to TM over BM equals to LM over AM. LT is the missing side, so we leave it as it is. Over AB, AB is 2, substitute AB by 2. and it is equals to Tm over Bm. What is the value of Tm? From the domain it is very easy to see that Tm in total equals to Tb plus Bm. That is to say Tm equals to Tb, that is 2x, plus Tm, that is 8 over 3. So in total Tm equals to 2x plus 8 over 3. Here, Tm equals to 2x plus 8 over 3 over Bm. Bm equals to 8 over 3. Here, Bm equals to 8 over 3. And it is also equals to Lm over Am. What is the value of Lm? Lm, from the domain it is very easy to see that Lm in total equals to La plus Am. That is to say Lm equals to La, that is the missing side, but plus Am, that is 10 over 3. So in total Lm equals to La plus 10 over 3. Here Lm equals to La plus 10 over 3 over Am. Am equals to 10 over 3. Here, the substitute Am by 10 over 3. So in conclusion, found out that Lt over 2 equals to 2x plus 8 over 3 over 8 over 3, and it is also equals to La plus 10 over 3 over 10 over 3. So in this long equation, those two sides, they are equal to each other. Therefore, create equation 1 from those two sides that are equal to each other. According to equation 1, we found out that Lt over 2 equals to 2x plus 8 over 3 over 8 over 3. So in this equation, equation 1, we have in this side of the equation Lt over 2, that equals to 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. 2x times x is 6x. So in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. So in this side of equation 1, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After we cancel 3, in this side we have to leave with 6x over 8, that equals to Lt over 2. So according to equation 2, Lt over 2 equals to 6x plus 8 over 8. Here we cross multiply this equation, equation 1, and found out that 8 times Lt equals to 2 times 6x plus 8. Here we divided this equation, equation 1 by 2, and found out that 3Lt over 2 is 4Lt. This equals to 2 over 2 is 1, so we left only here, in the other side of this equation 1, with 6x over 8. So 4 times Lt equals to 6x plus 8. Here we divided this equation by 4, and finally found out that Lt equals to 6x over 4 is 1.5x, plus 8 over 4 is 2. So we conclude found out that Lt equals to 2 plus 1.5x. Here, this side Lt equals to 2 plus 1.5x. Here we continue to focus on this long equation. In this long equation we have those two sides that are equal to each other. Therefore we get the equation 2 from those two sides that are equal to each other. So actually according to equation 2, we found out that 2x plus 8 over 3 over 8 over 3 equals to La plus 10 over 3 over 10 over 3. So in this side of this equation, equation 2, we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. 2x times 3 is 6x, so in total in the numerator of this expression we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. In the other side of this equation, equation 2, we have La plus 10 over 3. So here we multiplied La by 3 and then we divided by 3 in order to have a common factor with 10 over 3. La times 3 is 3La, so in total in the numerator of this expression we will have 3La plus 10 divided by 3, and we have to divide it also by 10 over 3. So in this side of the equation 2 we have 3 in the numerator and 3 in the denominator, so 3 get cancelled. In the other side of this equation, equation 2, we have also 3 in the numerator and 3 in the denominator, so 3 get cancelled. So what is left from this equation, equation 2, after we cancel 3 from both sides of the equation? We have to live with, in this side of the equation, we have to live with 6x plus 8 over 8. In the other side of the equation, we have to live with 3La plus 10 over 10. So in conclusion, we found out that 6x plus 8 over 8 equals to 3LA plus 10 over 10. Here we cross multiply this equation and equation 2 and finally found out that 10 times 6x plus 8 equals to 8 times 3LA plus 10. Here we divided this equation and equation 2 by 2 and finally found out that 10 over 2 is 5. Inside the brackets we have 6x plus 8. That is equals to 8 over 2 is 4. Inside the brackets we have 3LA plus 10. So in conclusion, we found out that 5 times 6x plus 8 equals to 4 times 3LA plus 10. Here we open the brackets on both sides of this equation, equation 2, and find out that 5 times 6x is 30x, plus 5 times 8 is 40. That is equals to 4 times 3LA is 12LA, plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 we get cancelled, we left only with 30x, that is equals to 12LA. Here we divided this equation 2 by 12, and finally found out that LA equals to 30x over 12 is 2.5x. So here this line segment LA equals to 2.5x in its length. Then I copied this small quadrilateral ABLT with the circle that is inscribed beside it in the new page. And we implemented rule 2 in the new drawing. Actually, this is quadrilateral ALBT with the circle that is inscribed beside it. Here we implemented rule 2. In the common external point A, from the common external point A, we have two tangents to this circle, tangent AM and tangent AK. And according to rule 2, they are equal to each other. That is to say, AK equals to AM according to rule 2. So if we define the length of tangent AK as A, then the length of tangent AM must be also equal to A because they are equal to each other. So in conclusion, we found out that AK equals to AM equals to A. Then we focus on the common external point B. From the common external point B, we have two tangents to the circle, tangent BM and tangent BH. And according to rule 2, they are equal to each other. That is to say, BM equals to BH. And so if we define the length of BM as B, then the length of BH must be also equal to B because they are equal to each other. So in conclusion, we found out that BM equals to BH equals to B. Then we focus on the common external point T. From the common external point T, we have two tangents to the circle, tangent TG and tangent TH. And according to rule 2, they are equal to each other. That is to say, TH equals to TG. TH equals to TG or TG equals to TH. So if we define the length of this tangent TG as C, then the length of tangent TH must be also equal to C because they are equal to each other. In conclusion, we found out that TG equals to TH equals to C. And finally, focus on this common external point L. From the common external point L, we have two tangents to this circle, tangent LK and tangent LG. And according to rule 2, they are equal to each other. That is to say, LK equals to LG. So if we define the length of tangent LK as D, then the length of tangent LG must be also equal to D because they are equal to each other. So in conclusion, we found out that LK equals to LG equals to D. Then we added side AB to the opposite side, side LT, in this quadrilateral ALBT. So what is the value of AB plus LT? AB equals to A plus B and LT equals to C plus D. So in total, AB plus LT equals to A plus B plus C plus D. Then we added side AL to the opposite side, side BT. What is the value of AL plus BT? From the drawing, it is very easy to see that AL plus BT equals to in total to A plus B plus C plus D. Again, AL plus BT equals to A plus B plus C plus D. So AL plus BT equals also to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. So you can write down that AB plus LT equals to AL plus BT. Here, AB plus LT equals to AL plus BT. AB is 2, and what is the value of LT? If LT is 2 plus 0.5x. So we substitute LT by 2 plus 1.5x, and it is equals to AL plus BT. AL equals to 2.5x, therefore we substitute AL by 2.5x plus BT. BT equals to 2x, therefore we substitute BT by 2x. So in conclusion, we found out that 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4. So in total, in this side of the equation, we have 4 plus 1.5x. That's equals to 2.5x plus 2x is 4.5x. Here we subtracted 1.5x from this equation, and finally found out that 4 equals to 4.5x minus 1.5x is 3x. So 4 equals to 3x. Here we divided this equation by 3, and finally found out that x equals to 4 over 3 units in its length. So the radius x of this circle equals to 4 over 3 units in its length. Our mission is to find out the area of this circle. And we know that the area of any circle equals to pi times the radius of the circle squared. So the area of our circle will be equal to pi, and the radius is x. Therefore, the radius squared is x squared. So the area of our circle equals to pi x squared. And we just right now found out that x equals to 4 over 3. If x equals to 4 over 3, it means that x squared equals to 4 over 3 squared. So x squared is 4 over 3 squared. Therefore, in total, the area of our circle will be equal to pi times 4 over 3 squared. What is the value of 4 over 3 squared? 4 over 3 squared is 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, we found out that the area of this circle equals to either 16 pi or 9 square units, or in terms of numbers, the area of this circle equals to 5.585 square units. Okay, thank you very much.